So there has been some confusion with people about how to do this assignment. So I thought I would walk you through one of the equations to try to give you a little bit of help with how to do these things. All right. So if you consider the reaction with magnesium and copper nitrate, it will form a brown solid. This would actually be copper metal that would form on the surface of the magnesium strip. Okay, so as we go to write out this reaction, so these molecular equations should all be reactions, the equation would look something like this. So Mg, all right, it's a solid, reacts with C with copper nitrate to make, now this is a single replacement reaction, so I'm going to go ahead and fix the subscripts because of Word. All right, there's a single replacement reaction, so the Mg is going to switch places with the copper. All right, this part's aqueous, so this is going to make magnesium nitrate, which is aqueous, and copper, which is a solid. All right, so we do this. Fix the subscript, and then we look at the reaction and make sure it's balanced. Now this reaction is balanced as is written, so we're good. Now let's take this equation and go down to the next table that says complete ionic equation. All right, now in chapter 15.2 we learned that ionic substances dissolve or dissociate in solution. What that means is that everything breaks apart into individual ions. Okay, so to make an ionic equation for this reaction, what we're going to do is break apart every single component into its ions. All right, so copper nitrate aqueous isn't really a chemical, it's broken apart into these ions. So copper is going to be 2+, and that's aqueous, plus we're going to have 2NO3 with a superscript -1. Over here, magnesium, well actually let's fix the copper first. Gotta love windows and cursors and clicking and all that, okay? So magnesium plus the copper ions plus 2 nitrate ions makes magnesium 2+ aqueous. Because again, it's an aqueous solution, so I got to disassociate the ions. Let's hit enter, so that this way this can all be seen easily on one screen. Actually, let's shrink this a little bit. All right, so this is what the complete ionic equation looks like. So everything that's aqueous like this is broken apart into individual ions. Okay, so that's how you write the complete ionic equation. Then the last question asks for the net ionic equation. So I'm going to take the complete ionic equation, all right, and then remove the ions that do not change. So copper goes from aqueous to solid, so it changes. Magnesium goes from solid to aqueous, so that changes. Later we're going to learn this is called oxidation because magnesium loses 2 electrons, and this is called a reduction because the copper gains 2 electrons. But for right now, for our purposes, what you need to understand is that the nitrate does not change, but that the magnesium and copper do change. They go from solid to aqueous or aqueous to solid. So because they do not change, we get rid of them. They are spectator ions. So erase this and erase this, and there you have a net ionic equation. So that's how you find the net ionic equation and the complete ionic equation and the molecular equation for the examples that we are doing in class. I mean, like online class. All right, I hope this has provided greater clarification on how this assignment works. So where am I getting the +2s? Well, if you look down here, I gave you the list of the metal charges and the charge for the NO3, the nitrate polyatomic ion. Of course, if you have any questions, please do feel free to reach out to me.